Hey there. In this video, we're going to be looking at Dalton's atomic theory. Firstly, it is important to note that his theories are based on the law of definite proportions and the laws of the conservation of mass. If you're unfamiliar with these concepts, I do have two videos on these concepts, so you can check those out. I have put the link in the description box below, so please watch those, and after you're finished, you can come back and watch this one on Dalton's atomic theory. Alright, let's get into it. So Dalton's atomic theory essentially has four main ideas, and you may see 5 or 6 depending on the source, but I decided to group them together to make it as compact as possible. And the first one suggests that everything is composed of atoms, the smallest indivisible building blocks of matter. Okay, so that means he thinks that all matter, everything there is composed of these atoms that are small and indivisible. So when we analyze this, it's important to understand what Dalton's understanding of the atom was at the time. He believed in the billiard ball model. I'll write that out here. The billiard, don't know if I'm spelling that right, billiard ball model. And what this is, and if you don't know what a billiard ball is, that's totally okay. It's basically like a baseball, or I think it's a pool ball actually. It's just a very hard wooden ball, and it's very strong, it's very hard, it's very, dense and massy. And this is what he thought an atom was. This was his understanding. As you can tell, there's nothing really inside this ball except for denseness. It's not very, there's no subatomic particles as we know today. So his understanding at the time was very limited, and that's why he thought that atoms were the building blocks of matter and that they were smallest and indivisible. All right. The next idea here states that all atoms of the same element are identical, while atoms of different elements vary. So what this suggests is that he thinks that maybe something like an element of carbon, would have different atoms than something like nitrogen. Right? And that is what he suggests by this. Maybe their properties will cause them to have completely different atoms, and he primarily bases this based off size and mass. All right. The next one here is very interesting. It's that compounds are a whole number combination of atoms. And this is where you see that connection to the law of definite proportions, which states that compounds are of constant proportion by mass of its constituent elements. So that's where the influence there comes in. So you can draw that connection here. So definite proportions, or the constant composition law, the same idea, definite proportions. All right, so that's going to be the connection there. And the final one here is that a chemical reaction is the rearrangement of atoms in reactants and products. And this relates to the conservation of mass. So you can see how these previous concepts really built in and influenced his theory here, the conservation of mass. And this one states that, mass cannot be created nor destroyed in an isolated system, and it indirectly suggests that, a chemical reaction needs to have an equal amount of each type of element on both sides, which, suggests that we need to have balanced equations, and that, in essence, a chemical reaction is the rearrangement of atoms. Okay, so now let's look at the limitations of his theory. Why are we not using this theory today? What went wrong? Limitations. And as we mentioned earlier, this billiard ball system in itself was a huge limitation because its understanding of an atom was quite limited. And that proposes the first limitation, and it's in the idea that the atoms are indivisible. Atoms are not indivisible, right? Are not indivisible. They're not, because in later experiments such as Rutherford will discover that we have subatomic particles. And our understanding, or the Bohr-Rutherford understanding of the atom, is the popular one. So you're going to have protons and neutrons, and then you're going to have electrons here. These are all different subatomic particles within the atom that can be divided. So that means atoms are not the most smallest indivisible building blocks of matter because there's protons and neutrons within it. So that's the first limitation there. The second one is that he suggests that all atoms of the same element are identical, but he doesn't consider isotopes. He doesn't consider isotopes. So, for example, and if you don't know what an isotope is, it's basically an element with a differing number of neutrons. It's still an atom of the same element because the number of protons are the same, but the number of neutrons are different. So the mass and the size are completely different. An example of this can be something like carbon 12 and carbon 14, where in carbon 12 you're going to have 6 protons and 6 neutrons, while in carbon 14 you're going to have 6 protons and 8 neutrons. All right, so that's the main difference here, that the size and the mass of this isotope is different even though it's part of the same element. All right. And the final limitation goes back to the billiard ball model and its understanding of the atom, and it's the idea that the atom occupies mostly empty space. The idea that the atom is very densely packed, but the truth is the atom is mostly empty space. And Rutherford does prove this. The atom is mostly empty with his gold foil experiment, and you can see it here. The most of the atom is composed of the orbitals in the Bohr-Rutherford diagram, and the Bohr-Rutherford model, sorry, and the center is very densely packed with protons and neutrons, but it is mostly consisted of empty space. This is unlike, you know, the baseball or the billiard ball model over here, because he suggests that the density is evenly distributed throughout the atom, that it's all very, very hard and compact. So that's another difference right there. Awesome. So, when it comes to Dalton's atomic theory, the main thing to understand is the progression, how the law of definite proportions and conservation of mass influenced Dalton's atomic theory, and it's an important part of chemistry as it is one of the first sets of atomic theory attempting to explain chemistry as a whole. So in this video, we looked at Dalton's atomic theory, we looked at how it relates to the law of definite proportions and the conservation of mass, and finally, we looked at the limitations of the atomic theory. If you enjoyed this video, please consider subscribing to the channel, and I look forward to seeing you guys soon.